Welcome to Catch This. My name is Trudy Ray. Multiple recent outbreaks of bird flu in U.S. dairies are raising concerns about whether milk from infected cows is safe to drink. H5N1, the strain of influenza virus causing the outbreaks, is typically transmitted among birds but occasionally spreads to non-avian animals, including mammals. In this video, I will discuss the risks associated with consuming milk from H5N1 infected cows. Don't go away. Prior to distribution, commercially sold milk is pasteurized using one of various methods. The most commonly used protocol involves circulating milk through a network of heated metal coils that are rapidly heated to 72 degrees Celsius, which is 161 degrees Fahrenheit, for 15 seconds, and then rapidly cooled to a storage temperature of about 3 degrees Celsius or 37 degrees Fahrenheit. This procedure inactivates all viruses and most other microbes, ensuring a shelf life of about 2 weeks. Although there are no known studies done to determine whether pasteurization specifically inactivates H5N1, this virus is sensitive to heat and is thus very unlikely to remain infectious after such a stringent heating process. Quantitative reverse transcription polymerase chain reaction analyses, or qRT-PCR, done on milk sampled from H5N1 infected cows have revealed that the milk can contain H5N1 RNA sequences even after pasteurization. To carry out qRT-PCR, viral RNA extracted from a milk sample is converted to DNA. This is the reverse transcription step. And the DNA is then amplified during the polymerase chain reaction portion of the assay. If H5N1 DNA is present, a small piece of DNA, a primer, binds to a complementary target sequence in the DNA, while another piece of DNA, a probe, attaches to a sequence downstream of the primer binding site. Binding of the primer initiates amplification of the target DNA by an enzyme called polymerase, which copies the DNA in one direction towards the probe. Once the polymerase reaches the probe, it cleaves it, which activates a fluorescent marker attached to the probe. The use of this fluorescent probe allows for monitoring of the fluorescent signal quantitatively in real time, rather than just detecting an accumulated end product. This technique, which was described in episode 1 of Catch This, linked above, only detects fragments of viral RNA, which are completely harmless, and does not indicate the presence of intact infectious virus. To detect whether infectious virus is present, milk samples are injected into fertilized chicken eggs, which are then incubated at 37 degrees Celsius or 98 degrees Fahrenheit for 2 to 3 days. Allantoic fluid from the developing chicken embryo is then removed from the eggs and subjected to a plaque assay. A plaque assay is a technique that allows visualization of infected cells on a petri dish. If the sample contains infectious viruses, the viruses will produce a circular zone of infected cells called a plaque. As far as we know, plaque assays done using H5N1 PCR positive pasteurized milk samples have not detected any infectious H5N1 virus, suggesting that pasteurized milk is safe to drink, even if it contains H5N1 RNA. Even consumption of unpasteurized or raw milk should not be a significant risk factor for H5N1 infection because influenza virus is transmitted primarily via the respiratory route. To sustain a respiratory infection while drinking H5N1 contaminated milk, a person would have to inhale virus particles that aerosolized from the milk, a scenario that is possible but unlikely. But it doesn't end there. The virus would then have to travel all the way to the lower respiratory tract because human upper respiratory tract cells do not have the surface receptors that are needed for entry of avian influenza viruses, a concept discussed in episode 45, linked above. H5N1 is more likely to infect humans through the eyes because, like cells of the lower respiratory tract, cells of the human cornea and conjunctiva do have the receptors needed for avian influenza viruses to enter. Ocular infections with H5N1 typically lead to conjunctivitis, as exemplified by the only dairy farm-linked case of human infection reported so far. Nevertheless, I would caution against the consumption of raw milk, which is known to contain a variety of pathogenic bacteria, including Campylobacter, Yersinia, Cryptosporidium, Staphylococcus aureus, E. coli, Listeria, Brucella, and Salmonella. In fact, raw milk is one of the most dangerous food products and is responsible for more hospitalizations than any other foodborne illness. Based on all the available evidence, pasteurized milks and cheeses remain safe for consumption, even if they contain fragments of H5N1. Despite the recent outbreaks in dairy cows, there is only one documented case of human infection so far, linked to the dairies, in a dairy worker who likely became infected directly from a cow. There is no evidence that H5N1 can transmit from one human to another, a criterion that is essential for triggering a human outbreak or pandemic. Although the virus does appear to spread between cows, this transmission seems to be mediated through milking machines rather than via the classical respiratory route. It appears that cells of the bovine mammary glands have the necessary cell surface receptors that enable entry of avian influenza viruses, suggesting that the virus may spread from cow to cow when udders come in contact with contaminated machines. Although H5N1 may eventually evolve to transmit efficiently between humans, we are probably better prepared for a potential H5N1 pandemic than we were for the COVID-19 pandemic. At least 3 effective FDA-approved antiviral drugs are readily available, and several experimental vaccines are also in development. The incidence of H5N1 infection in both humans and animals should be continually monitored, so that any person-to-person transmission can be immediately detected and contained. That's it for today. Thanks again for listening. My name is Trudy Ray, and I will see you next time on Catch This.